This is Michael King. In this short video, we're going to look at how to build a two-stage dividend discount model in Excel. Here we have an Excel spreadsheet where we have a question. A company expects to pay dividends of $2 at the end of this year, dividends of $3 and $4 at the ends of years 2 and 3. Estimated dividend growth is 4% after year 3. What is the price if the expected return is 11%? As you can see, I've already built a table that can be used that we can fill out to make a two-stage dividend discount model. In the first column, we have the periods. Next column is growth rate of dividends and the dividends themselves in the third column. So let's start by putting in the dividends. Notice that period 0 refers to today, and the company expects to pay the dividends at the end of this year. That means 1 year ahead. So what we're going to do is we're going to put in $2 1 year ahead. Dividends of $3 and $4 at the ends of years 2 and 3. So we put in our $3 and our $4. Estimated dividend growth is 4% after year 3. So at this point we need to put the growth rates in. Notice that the growth rate is going to be 4% in perpetuity. So we're going to be simply referring to the cell of 4% and dragging it down to illustrate what the growth rate would be. So here in cell C12, I'm simply going to take the dividend of $4 in the previous period and multiply it by 1 plus the growth rate of 4%. See that the dividend grows to $4.16, grabbing the bottom right and dragging it down. Using relative referencing, you can see I'm always referring to the cell above, and it's growing by 4%, which is the growth rate in column B. Okay. Now the thing about a two-stage dividend discount model is that this goes on in perpetuity, so we don't want to actually have to drag out these dividends in column C forever. So what we're going to do is we're going to acknowledge that starting with the constant growth in year 4, we can value the company at the end of year 3 using this formula. You see the formula is that the price at any point is the dividend in that year grown by 1 plus the growth rate divided by K minus G. Now notice that we've only forecast dividends for 10 years when in fact the dividends will be going on in perpetuity, meaning that they will continue to grow at 4% from this point onwards. But we don't want to have to forecast all those dividends, although it would be possible with Excel. Instead, what we're going to use is we're going to use this formula here, the constant growth perpetuity formula, to figure out what the value of all the dividends are going to be once the growth rate is constant. Notice that the growth rate is constant starting in year 4. So to figure out the price in year 3, we would use the dividend in year 3 and grow it by 1 period, which is also the same as the dividend in year 4, and divide it by K minus G. So effectively, we're going to be acting as if we sell the stock at the end of the 3rd year, and the price at which we're going to sell the stock is going to be the dividend of $4 grown by 1 plus the growth rate, which here is in cell B12, divided by, open brackets, the difference between the discount rate, which we do not have yet, so we're going to have to put in a discount rate. I'll just refer to this cell here, which is blank, minus the growth rate. Okay, close brackets. Okay. Now for this to work, we have to put in the discount rate, and the discount rate is going to be 11%. Okay, and you can see that it's often helpful when putting assumptions into a model to highlight them in yellow. That's an old convention. So we know that these are assumptions. These 3 dividends we entered as numbers, and this growth rate we entered as a number. Okay. If you want to see where the formulas are, you'd use Control tilde, which is on the very top left in my case, and you can see all the formulas as they are shown in this spreadsheet. Okay, I'm just toggling between showing the formulas and showing the outputs. Okay. So this $59.43 at the end of year 3 actually refers to all the dividends that will be coming in years 4 and onwards. So I'm just going to, for visual sake, I'm going to put some borders around this so you can see what I mean. Okay, so now we have these 3 dividends, and we have the value of all the dividends for year 4 onwards in terms of the price at the end of year 3 using this formula. Okay, so what we want to do is we want to sum up the cash flows. We have our the cash flows from the dividends plus the terminal value. We can simply drag this down, and you can see that the cash flows are now at $2, $3, and $63.43. We're going to refer to our discount rate, and here I'm going to use absolute referencing using dollar signs. I just hit F4 for adding dollar signs for both, and I drag that down. And what I like to do is I like to show my present value interest factor separately from the calculation so that I can see if it's correct. So I'm going to put equals 1 divided by 1 plus the discount rate, which is just to the left, close brackets, raised to the power of the number of periods. Okay, and notice that I get a value of 90 cents, which means $1 received 1 year in the future, discounted 11%, would be worth 90 cents today. I'm going to multiply my cash flows times this discount factor, and I see that $2 received at the end of 1 year, discounted at 11%, would be worth $1.80 today. And if I drag this down, I can see that that $3 dividend is worth $2.43, and this $63.43 cash flow received at the end of year 3 is worth $46.38 today. The price is simply going to be the sum of the discounted cash flows that you will receive. I'm using the sum function, and you can see that the answer is $50.62.